Hello grade 12s, welcome to my channel. And question 3 of the exams you wrote came into my attention, so I figured let us just have a look at it and sort it out. A student of mine mentioned how she approached it and it was pretty impressive, so let's go on and we'll get to that 3.7 and point out how it is done. Okay, great. So we've got 3.1. Oh, before we start answering, we read. Why am I doing bad things, bad habits, table manners, eh? Okay, now in the figure, L with coordinates -4 and 1. And, oops, that is too big. That is too big. Okay, and with S with coordinates 4 and 5, point in the first quadrant, and -2 and -3, which is the point in the third quadrant, are vertices of a triangle having SLN equals 90 degrees, and we can see that it's drawn. LN intersects the x-axis at K. That is quite obvious. Now what can we do here? We've got 2 points on LN. We can do the gradient. From the gradient, using one of the points, we can get the equation of the line. From the equation of the line, we can work out the x-intercept K. Now on LS, we've got 2 points. Again, we can find the gradient. With the gradient and one or any one of the 2 points, we can find the equation of that line. And from the equation of the line, we can work out the y-intercept. Now SN, we've got 2 points. We can find the gradient. From the gradient, we can find the angle of inclination, theta. And from the gradient together with any one of these points, we can work out the equation of this line. From that equation, we can find the x-intercept as well as the y-intercept. So pretty much this is a grade 11 question, and usually most of the things can be done something too. It's very rare that they leave out some information. Either way, let's answer it with attacking it quickly. 3.1 says calculate the length of SL. Okay, that is that side. So SL is equal to the square root of x at L minus x at S all squared plus y at L minus y at S all squared. Okay, so this implies that we've got that square root. X at L is -4 minus 4. Wow, -4, okay, all squared plus 1 minus 5 all squared. Now that goes into the calculator. Can't find it. Okay, let's find it. Let's find it. Let's find it. Let's find it. Hoops, hula hoops, hula hoops, hula hoops. Okay, what we have here is the square root of we've got the square root of -4 minus 4 all squared plus 1 minus 5 all squared. That gives us a 4 root 5 units. Okay, so that's easy. So with the length, please don't forget the units. They are important. All right, so the next question, marks, 2 marks, so that is fair. Substitutions and the answer. Now 3.2, it says calculate the gradient of SN. So we've got 2 points there. So SN is going to be y at N minus y at S over x at N minus x at S. Okay, so that is the gradient. Maybe let's write it better. we can say MSN. Okay, so the y at n is minus 3, y at s is minus 5 over, now x at n is minus 2 minus 4. So this is minus 8 over minus 6. So this is basically 4 over 3. Okay, so that is the answer right there. Okay, so what do you get here? Marks for those substitutions and the answer. 3.3. We've got to find the size of theta. Now we've got the gradient, we can sort it out. So we know that here tan theta is equal to the gradient of Sn, that is its angle of inclination, which implies that tan of theta is going to be 4 over 3. Therefore, theta is equal to the shift tan of 4 over 3. Which we can get an answer there. Let's get it. Shift tan 4 over 3. We get 53.13 degrees. So 53. I went 125 from 10 53.13 degrees. Of course, I'm rounding off to 2 decimal places. You will check on the instructions. I don't have them on this picture. So we're getting 2 marks also. So this substitution here and getting the answer is the 2 marks. Okay, 3.4. Now we're told calculate the size of LNS. Okay, where is LNS? Now, you can see that this angle is this angle right here. That's LNS. Okay, but now where is it? We can see there that, well, if we look at it nicely, we'll see that theta could be equal to this angle right here. So if we've got theta here, then this angle is theta. Okay, and those are vertically opposite angles. So this drives us into this triangle. Now this angle plus that angle gives us the angle of inclination of that that LKN line. So the key is to find the gradient in there. So we have this triangle here to work with. So this triangle, we must fix it like so. So now we can see that is our working area, and we just need the gradient of Ln to find us that angle of inclination, and therefore we can use the exterior angle of a triangle to get that. So we can simply say, essentially, tan, what is that angle? LKO is going to be equal to the gradient of Ln. Okay, that is its angle of inclination. We can see that this implies that tan LKO is equal to, at this point there's no need to waste time trying to write formulae and stuff. We just jump in. It's going to be 1 minus 3 is going to be plus 3 divided by minus 4 plus minus 2, which is going to be minus 2 is going to be plus 2. So now that implies that our tan of LKO is equal to minus 2. All right, so that means our LKO is going to be shift tan of minus 2 plus 180 degrees, right? Because it's an obtuse angle. So let's get it done. Shift 10 minus 2 plus 180 is equal to 116,565 degrees. So on the intermediate step, I just go one extra digit on the decimals so that it's not going to mess up my accuracy for the answer. So now we have that exterior angle. So we can now state that in triangle, and in fact we should have just done that already in the beginning because that's the triangle we're working in. I don't know why I'm sweating here. So let's do it. We're going to state here that in triangle KON, because that is what we're trying to work on. We just have to say here also, we know that angle KON is going to be equal to angle theta, which is going to be equal to 53,13 degrees. What is the reason? These are the vertically opposite angles, and it's done. So that means, therefore, KON is going to be, we can say then, okay, we know that essentially angle LNS plus that angle KON should be giving us LKO. Now that is the exterior angle of a triangle. Again, we stated which triangle we are talking about. And then let us sort it out finally. This implies that our LNS plus this is 53,13 degrees is equal to 116,565 degrees. Then we can make our conclusion that our LNS is going to be the difference of 116 degrees, 116,565 degrees minus 53,13 degrees. This gives us a 63,44 now to 2 decimal places. That should be the answer. Okay, good. So that solution is done. So again, this is hiding the fact that this is a higher order question. It's really not a simple question, so you just have to plan. It's an indirect type of question. That's what makes it a higher order question. You can see it's a bit of an essay for just 3 marks, which is crazy. Anyway, so getting here to calculate this gradient, it's important, right? And to calculate this angle is important. And the final answer is important. The rest is just stuff that IA means to an end. Okay, 3.5. I told you, determine the equation of a line passing through L and is parallel to SN. Write your answer in the form. So they want this in a standard linear format. Okay. So let's see, where's this line? So there's a line passing through there. Obviously, it's not going to be exactly straight because now I'm just trying my best. So there is that line. It's parallel to SN passing through point L. Okay. So obviously, we know that the gradient of the line, just going to annotate it as L, is going to be equal to the gradient of SN. Right? What is that? Those are the parallel lines. So we can say parallel lines have equal gradients. Okay, therefore the gradient of this line is equal to 4/3. Okay, so we can say then, or this implies that this line is such that y is equal to 4/3x plus c. Ne? Then through point L, which is -4 and 1, 1 is going to be equal to 4/3 into -4 plus c. Therefore, our c is going to be equal to, essentially, this is going to be, it's just 1 plus 16/3. That gives us a 19/3. So what can we conclude? We can conclude therefore that our line is going to be y is equal to 4/3x plus 19/3. Now that is the line. Does it make sense? Well, it has a positive gradient, a positive y-intercept. We can accept it, although the numbers may be the ones that can be a problem. So what are the marks here? Essentially, noticing that this is the case, it's important that correct substitution of that point and the final answer. So this is the standard 3-mark question, so there's nothing special there. 3.6, we're told you calculate the area of triangle LSN. Okay, so we can see that this side is drawn perpendicular to that side, and we've already calculated LS, so that means we just need the height LN. So we can just say in triangle LSN, what is going on in there? We know that we are supposed to find LN is going to be equal to the square root of x at n minus x at L, all squared, plus y at n minus y at L. So this means we are doing it. X at n is -2, minus -4 is going to be +4, all squared, plus. Now y at n is -3, -1, all squared. So let's find that distance. So we've got the square root of -2 plus 4 all squared, plus into -3 -1 all squared. So we're getting a 2√5 units. Okay, so that is important. So it's an intermediate step, we leave it like that. We can say then the area of triangle LSN is it? Yes, is equal to a half base times height. Now this is a half of the basal side. We're going to say SL, sorry, times LN. Okay, substitute. This is a half SL. We found 4√5 above, and then this one is 2√5. Does it turn in Palis to be in Palis Babai? This is equal to a half of 4√5 times 2√5. Okay, so this is equal to, now this is half of 4 is 2. 2 times 2 is a 4. Square root of 5 times square root of 5 is just 5. 4 times 5 is 20 square units. Okay, so that is the area of our triangle. So what is important is this calculation, the substitution, and the answer. 3 marks. Okay, nice question there. Now let's do the 3.7, which caused problems. Okay, let's just do it right. Now it says calculate the coordinates of point P. Can you see coordinates of point P, which is equidistant from LSN. Now watch the sequence of naming those points. LSN. Okay, now what do we do here? Now the most important thing for us to do here, if we are to find a point that is equidistant from N, from L, from S, we need to consider a parallelogram that is made up of these sides, but in the sequence that was given, L, S, N. So that means we can do this parallelogram in this region. Okay, and we join it. Okay, so there's our parallelogram. Of course, it's not gonna be perfect, but it gives us an idea of what we're dealing with, because we did not distort the diagram. The most important thing is to not distort this diagram, and don't change the sizes of these angles that are already here. You're just being creative, and you're using your creativity as a means to an end. Now we can see that essentially we know something, that the diagonals of a parallelogram actually bisect each other at a common point. If that is the diagonal, and this one becomes another diagonal, okay, so where do they meet? They meet there. We can call this point P. So we're making this point P, which is that point we're supposed to find. Why are we saying this is point P? Because we know the diagonals of a parallelogram bisect each other at a common point. But now this one is special because of this 90 degrees here. Because of that 90 degrees, this makes it a rectangle. It's not just a parallelogram, it's a rectangle. A rectangle, of course, because it's a parallelogram first, this is going to be 90 as well. And now we know that since these lines are all parallel, as we can see here, that this line will also be, okay, maybe let's do it this way. This line is going to be parallel to this line. Maybe let's make it 3, okay? So can you see those lines are parallel, as well as these lines are parallel. Okay, so we can see that if this is 90 degrees, this line being parallel to that, these are co-interior angles. So essentially all of these corner angles are 90 degrees. This is what makes this one a rectangle. A rectangle. So now we can tell that this will essentially be a parallelogram that is effectively a rectangle. Now this makes life easy because you know all these diagonals are going to bisect each other, and at the same time they are equal. That's the most important. Now let's go on and solve point P. We can just say construct parallelogram L, S, Q, N as shown. Of course you will have shown this, right? Goodness. Such that, now as we can see here, first of all, we can simply say, now we can see that essentially this L parallelogram LSQN is a rectangle. Okay, Why? Because the corner angles are 90 degrees. Okay, that's number one. That implies that point P is the midpoint of SN. Okay, great. What do we know? We know that diagonals of a rectangle are equal first and bisect each other at a common point. Okay, so the reason can be a bit wordy as well, but I mean, that is what we have to do. That is what we have to do. So this implies what? Now it means that P is the point where we can say x at S plus x at N over 2 is to y at S plus y at N over 2. The reason we're choosing Sn is because we know the coordinates, so we couldn't choose Q because Q is effectively x is to some value y. Okay, great. So which also implies that our angle P now is going to be 4 minus 2 over 2 is to 5 minus 3 over 2. Okay, therefore point P is 1 is to 1. Okay, good. So this one is a higher grade question, guys, that is hidden from the fact that it is a higher grade question, and it makes you sweat a little bit more. They are hiding it by using small anyana marks to fool you that they're actually taking you down, and you better be very careful. This is a hidden suplex sit. It's one of those guys who come and steal the title when the wrestler is tired from a fight with another wrestler. Then they just come and do the, what you call, money in the bank stuff, and then they cash in and you cannot fight anymore, and then they win. So these are the kinds of the questions. These are the sly questions. So I was impressed that my student actually had an idea and got these coordinates without knowing she was doing the right thing. You see, sometimes math, once you experience a little bit difficulties here and there, you start to have the right thought process. It may not be perfect, but it won't be far from the truth, and that means you're going to get some marks. Okay, so let's get the marks here. Obviously, these two coordinates are important, right? And the rest of this construction and the statements and whatever are very important. Okay, great. Now let's do the last question. 2.8 says calculate the size of LPS. Okay, so where is LPS? LPS is essentially this angle LPS. So this is the angle that we are looking for. Okay, but now what do we see here? This angle LPS is an exterior angle of this triangle, right? So what do you notice about this triangle here? That triangle is effectively an isosceles triangle. Can you see this side is equal to that side? So this means this angle right here, which we already know is going to be equal to that angle there. Those are the angles opposite equal sides. All right, good. So that was the mistake I actually committed when I did the initial video. In any case, I was doing it in a hurry, so some mistakes always try to find you. So actually, not that it is bisected, because in a rectangle those angles are not bisected, but now that we know the diagonals are drawn, they create isosceles triangles, you know, one opposite the other. All right, so that means we know the size of this angle. We essentially know the size of that angle, and that is an exterior angle, so it will come out just right. So we can just simply say in triangle LNP. What can we say in that triangle? We know that essentially angle NLP is equal to angle LNS equal to, what did we get? We got LNS is 63,44. So this is 63,44 degrees. Okay, now what are these? These are angles opposite equal sides. Okay, we can say here safely then angle LPS is going to be equal to the angle LNS plus the angle NLP. That is an exterior angle of a triangle. So that is the triangle we're talking about. And then we just simply substitute. This implies that LPS is going to be equal to 63,44 degrees plus 63,44 degrees, which we can make our conclusion. Therefore, our angle LPS is double those angles. So 63,44 times 2 is essentially 126,88 degrees. All right, so that is the answer to the last question, and that is how one could take those 20 marks. Probably not so happy, but not so angry at the same time, because the only challenge was probably these last two questions. They are both higher grade questions because it's not so easy. Again, they're hiding it by just giving you small marks, and that is how this question should be attended to. Okay, so that is it, guys. How many marks are we scoring here? Just 2 marks. Obviously, for me, what matters is this portion here where we substitute and the answer. The rest is just a means to an end, which we needed to make sure we reconcile. Otherwise, guys, apologies for the video that I posted rashly, because I thought I could do it quickly, but then I had some commitments to rush to, so kind of rushed without noticing that I'm committing an error regarding our parallelogram. But the parallelogram is effectively a rectangle. So those are the things you need to be aware of, guys, when you practice Euclidean geometry. You need to know all. You need to know all and be comfortable. You can't go there panicking. But sometimes I understand, as some have said, this thing is disheartening as well, because you work so hard, then they come up with some questions like this, and you feel like, well, I simply wasted my time. My advice is, don't be beaten by these things to a point where you don't like your maths. Just know this is a challenge you have to face for a little bit, but going forward and beyond, you will be able to love this, because you will see its practicality and you will start to enjoy the fact that you did it. The A must be a distinction, guys. Don't worry about the 100%. It really doesn't matter. Okay, guys, I hope you enjoyed the video, and again, apologies for the incorrect video that I posted earlier. I hope this one will make up for all the mistakes that I almost fed you. All right, goodbye.